Yeah, so I'm very excited to be here. Thank you, Philippe, for having me. Yeah, so basically, the idea um, of this talk is like, so you're doing a code review, and maybe there's something that you see all the time. You're like, hey, like I see you're using this function, say ensure user, but just our code base has migrated. We're not doing that anymore. We have this other helper called ensure logged in, or whatever it is. And sort of the idea, sort of the motivation of this talk is like, every code base has implicit or explicit assumptions, perhaps requirements or coding standards, just like this is how our code works. And this may be different than, say, Ruby in general, or even a Rails app in general. Like every code base has like its own intricacies, right? There are a number of super great tools that cover sort of generic, say, Ruby or framework checks, like Rubocop and Brakeman, for example, I think are awesome tools. But the thing is, like, those can't cover, or at least out of the box, they don't cover things unique to your project and your company and organization. But I think there's a lot of value there in customizing things for your code base, because obviously you have a lot of domain knowledge that these tools who have never seen your code don't. And I guess at a high level, the idea for this talk is like, you have all these coding standards. Maybe these are in static documentation, say on your wiki. Maybe they are just implicit in the code itself. And maybe they're just in your or someone else's brain. People who have been developing the software for a long period of time, and they're like, oh, these are the things we do. This is how we should do things. And the idea is to go from these sort of like static coding standards or implicit expectations and move from it being something that you have to remember, something that you have to like actively comment on pull requests, things that you have to teach new developers who join your team, and take it from just your brain or implicit to something that's explicitly checked continuously in CI. For example, in GitHub Actions, there's, you can plug in a bunch of linters. But if you use Travis CI, GitLab, and others, those are equally sort of applicable. So basically, it's like, how do we take what's in our head and make it continuously checked automatically? Because obviously we're lazy, and we would like to not have to sort of like manually do these things over and over again. So just to make this a little bit more explicit, like, why do we care about writing these sort of code base or organization-specific lints in the first place? Again, we can help new developers get up to speed faster, start contributing better to the team. Ideally, we can ship higher quality code more quickly because we're not sort of slowed down by these sort of sharp edges or things that are maybe implicit that we forget. If you're like a big engineering team or many orgs within the company, ideally you can, say, enforce calling conventions or have a high code quality standard across your org. Like, this is how we do, say, authentication or authorization within our code base. So whenever you spin up a new microservice, please do this, and sort of keeping that expectation consistent across your organization, hopefully minimizing some spaghetti code. If you come across like common bug classes, they're like, this API is a little bit finicky. Like if you don't call it with like the third parameter being like a constant, or if you don't do one of these two values, like it's a bug, you can sort of codify this type of bug class so that it doesn't happen again. And ideally also you can prevent some security vulnerabilities. So basically that's sort of the motivation and goal for this talk. So before I get into it, a little bit about me. So my name's Clint. I'm the head of security research at a San Francisco-based startup called R2C. So we're basically trying to sort of improve software quality and security as much as we can. So the tool I'm going to be talking about today is called Semgrep, which is totally open source, and there's a bunch of rules that are also open source. One thing people often ask is like, this is great, but like, how do you make money? So we have like a SaaS app that helps like manage things at scale and do like metrics and stuff like that. I'm not going to talk about that basically at all during this talk. I'm going to focus on totally like open source tool, open source checks that you can use like right after this if you want, without even talking to us. It's just on GitHub, and I'll show you some links. Yeah, so before this, I was at Semgrep, which is a global security consulting firm. And before that, I was a grad student at the University of California, Davis, where I dressed like this, as all grad students do. Feel free to reach out on Twitter. I'd be happy to chat. And I also have a security newsletter called TLDRSec. So feel free to check out that if you're into security. So the structure of this talk is basically a little bit of background on like if you were wanting to create custom lints for your code, like what are various tools and approaches you could use, and like what are the trade-offs between those. Then we'll talk a little bit about some hands-on examples of using Semgrep. We're going to write some queries live together just to show you what it looks like, and it's pretty easy. Then we'll talk about some advanced features like integrating with CI, stuff like that, and finish with more time for questions. But really, just interrupt me whenever you want. If you have a question, probably 5 other people do as well. So I'm going to stop often and ask for questions. So feel free whenever you want. Don't feel like you have to wait till the end. OK, so yeah, I guess before I get into it, any questions so far? Cool. Well, yeah, feel free to put it in the chat or just unmute, whatever you want. So, OK, so let's say you're like, this function is like dangerous. We shouldn't call it anymore. What's like the easiest thing we could do? So one thing is using grep or ripgrep, which is sort of like a faster version of grep. It's great. It's installed everywhere. It's super easy to write checks via like regular expressions, easy to iterate. But unfortunately, it's not source code aware. And I'll talk a little bit about what I mean by that in a second. And also, you're having to like write everything from scratch. So that's not ideal. You don't have sort of checks out of the box that you can use. Maybe there's some like gists or other repos that you can borrow from, but generally, it's just a tool, and then you write what you want with it. So obligatory Xkcd reference. When you're using grep and writing a bunch of regular expressions, like maybe it finds what you want now, but in the future, if you have to edit it, as it gets more and more complicated, probably not that easy. And talking about how grep is not source code aware, what I mean is when grep looks at code, it just sees the code as a string, but code isn't really a string when it's either compiled or interpreted by, say, the Ruby interpreter, for example. It actually processes it as a tree. Right, so it's like it's not just like, oh, this is this text. It's like, oh, well, this is a function call. This is an assignment. This is a for loop or something like that. So ideally, we want to be operating more at this tree level, specifically like abstract syntax tree, because we want our tool to be aware of the source code structure so that we are not sort of flagging things that don't actually matter. And we'll look at some examples of that in a second. So there are, again, a number of great tools that basically operate essentially at the sort of S expression or abstract syntax tree level. For example, Rubocop and Brakeman are great examples. So these two tools are source code aware. They do come with many checks, so this is both great. But they're not as easy to write custom checks with, right? So you need to understand, like, how do you write custom rules for these tools? What sort of APIs do they provide? What sort of primitives do you need to express your logic in, and things like that. So definitely, I'd say overall better than grep, at least for some purposes, but it's not quite as easy as perhaps we would like. So is there anything else that we could use? So there's this tool called Semgrep that I'm going to be talking about today. And this actually is a pretty old tool. It was originally created, I think, around 2008, 2009 at Facebook, where it was used to sort of enforce secure coding patterns. It's very customizable. It's lightweight. If you're familiar with, for example, traditional security static analysis tools, they're called like SAST tools, where basically they can take many hours or days to run. This is, Semgrep is sort of a middle ground between grep and these very heavyweight tools. It's sort of like, how do we combine the best of both worlds, where how can we be like fast, but also sort of more precise than grep, but not as sort of slow and inflexible as these existing tools. So there's hundreds of existing rules. Offline, runs on, I say uncompiled here because it covers a number of different languages, not just Ruby. It's open source on GitHub, LGPL. And I think one of the key things that's very interesting about it is that you don't need to learn a separate fancy domain-specific language. The patterns you write when you're targeting Ruby code are basically just like Ruby with a couple of abstractions, which we'll talk about in a second. So comparing this to the other existing approaches, I think it has, it's not perfect. We'll talk about some limitations in a minute, but I do think it has some strengths as opposed to these other approaches. So, OK, so now I'm about to go into a few examples, which will sort of like live solve some example coding patterns we want to find together. But does anyone have any questions so far about like how, I don't know, like abstract syntax tree matching works, or just sort of this like background and motivation? But the bulk of this talk, which we're about to do, is sort of like hands-on examples.
One of the things I was interested in is you didn't talk about CodeQL and kind of how that stacks up against this, which is they're a semi-new player into this.
Yeah, totally. That's a great question. Yeah, so if you think about like a spectrum of complexity, where sort of grep is very like simple on one side, and then I would say on the other end of the spectrum is CodeQL, which is doing full program analysis. Semgrep is basically in the middle between those two. So there's certain fundamental trade-offs you need to make when you're doing program analysis in terms of like, do you want to reason about how data flows through your program across many files, perhaps dozens or hundreds of files or thousands of files, versus do you want to analyze in sort of a more localized fashion? And you basically, depending on sort of where you turn that knob, you can either be very fast, but perhaps not as expressive, or you can be very expressive, but a lot slower and have some other limitations, such as you need like buildable source code or an environment that can sort of fully resolve types. Yeah, so basically, happy to chat about this in more detail, but basically on the spectrum, it would be like grep, Semgrep, and then CodeQL, going from simplest to most advanced. So Semgrep focuses on being fast and doing local analysis, and CodeQL focuses on being able to do like taint analysis across, say, like hundreds or thousands of files. But in order to do that, it can make it a little bit slower, and it needs to have a buildable environment so that it can resolve like types and method calls and things like that, where Semgrep does not need buildable source or to be able to fully resolve types to do its analysis. And I think the DSL is a little bit simpler, which we'll see in a second. But yeah, that's a great question. Does that answer your question?
Yep, does. Thank you.
Cool. Yeah, thanks for the question. Any other questions? Cool. Well, yeah, feel free to interrupt me whenever. So just to give you a little flavor about writing patterns for, say, RuboCop and Brakeman, we'll just look at some examples. So on the right side, let's say we want to do something pretty simple, which is we want to find all calls to eval, because that's potentially dangerous if a user could control input to it. So RuboCop does have a rule for that. By the way, there's a link to these slides at the end, so don't feel like you have to write everything down. You can just go to it. So here's basically how it looks in RuboCop, where defines this node matcher. It's like, hey, call eval. And basically, this is doing some like S expression matching, where it's looking for like, is it binding.eval versus just eval? And then is its argument like a string or not? And let's see, yeah, like, is it being called on a string? Is it a literal versus potentially a variable? And then like warn if so. So this is like not terrible, but it's a little maybe not easy if you're not familiar with S expressions or sort of their internal DSL for how to write rules. So let's look at an example of how you might find this with Semgrep. So this is semgrep.dev, which is basically just a way to like run Semgrep in your browser without installing anything. So you can write some patterns in here, and then this is the test code that you're running against, and that's pretty much it. OK, so I said before that Semgrep is basically like you're writing whatever code you're targeting, for example, Ruby, but like with a couple of abstractions. So one of the abstractions is the ellipsis operator, or we call it like the ... operator, which basically says like match 0 or more arguments. I don't care what's inside. So basically, if we run this, we can say like, okay, so we found eval with parens or without parens, or if it's like a string literal variable. And already we're seeing some benefit of using an abstract syntax tree or like a non-grep type approach, because grep would probably flag this, but it's not actually eval. It just, like if you were to say eval open paren in your regular expression, you would probably have like a false positive here because it's not actually eval. And having a regular expression that can handle white space across multiple lines, and maybe it's in a comment, maybe it's in a string literal, like pretty soon regular expressions are going to be pretty hard pressed to do this. But this is maybe not quite what we want, because really, if it's potentially dangerous, like a string literal is probably not a threat. We ideally want to find calls to eval where the argument is not a string literal. So one interesting thing you can do is you can have sort of a Boolean composition of various clauses in Semgrep. So you can say like, this must be true and this must be true, or this but not that, or either of these can be true. So we can actually add another clause here and say, we want to find eval called with any arguments. We don't care what they are, but we want to filter out calls to eval where the argument is a hard-coded string. So this ... inside of quotes is sort of a shorthand for saying like any string can be in here. It doesn't matter what the text is. So if we run that, we can see that we are no longer flagging these because they're just hard-coded strings, but we are flagging these other cases which are potentially dangerous. So yeah, so basically the DSL here is we are using the ellipsis operator to match 0 or more things, but we don't care about what they are. And we can sort of combine clauses to either add to the scope of what we're matching or to filter things out. And one thing that's nice is it's sort of like you just look at it and you kind of feel like you're like, oh, this is probably what this would match. Yeah, any questions so far?
Is this UI that we're seeing, is this the still like we're in open source land, or is this the SaaS product?
Oh, this editor is, the editor UI itself is not open source, but it's totally free. You can use it now. You don't need to log in. Yeah.
Thanks.
Yeah, so just to give you, I guess, perhaps a better understanding, just because you asked. So we have maybe 750 rules that are like totally open source. You can use those as much as you want. Semgrep, the tool itself, totally open source. Do whatever you want. This editor is not open source, but is free. You can use it as much as you want. You don't have to talk to us. You don't have to log in. You don't have to pay us, whatever. Well, cool. Yeah, great question. Any other questions? Cool. Yeah, feel free to interrupt me again whenever. So here's another example of, say, finding divide by 0. This is a check from Brakeman where basically what it does is it has some like super useful helper functions where you can like find calls to specific methods by name. So here it's finding all calls to the division operator, and then it calls this check division helper on the result. And basically it gets the call from it, looks at the first argument, and then is like, oh, is the denominator a 0 or not? Okay, so like how might we express this? So we're going to look at another sort of abstraction that Semgrep provides, which is an abstraction around like, oh, maybe I know that this is going to be a thing, but I don't know what its value is. So we call this a meta variable. So basically, if you do $sign and then any all caps text, this will match like any value. So if we just say like this could be anything, it could be like an integer, it could be like a variable, I don't know. We can see that this matches a couple different things. So matches just when it's an integer. This matches the right-hand side of like a variable assignment. But one thing that we're like not matching that would be kind of nice to match is this case, where it's like, okay, well, we're assigning something to the value 0, and then we're using that after. So how can we match that? So we can actually say something like, well, let's say there's like some variable, it gets assigned to 0. There's like some other stuff that happens. So this dot operator can mean not just 0 or more arguments. It can mean like 1 or more statements. And then at some point, there's going to be some sort of like maybe like another assign that's, I don't know, we don't care what it is, but it's divided by this thing that we know is 0. So yeah, so we can see that now, because we added this additional clause, we're flagging this second case of, and if we wanted to, we could say like other stuff happens in between. These don't have to be sort of like directly adjacent statements.
Quick question.
Yeah.
I'm curious about the choice to include the assignment in the second pattern, rather than have it and x over var.
Yeah, that's a good question. So the reason I did that is, to be honest, because like as I was writing it, I was like, I'm not sure this is going to match, because I'm not sure if this is going to be looking for like a full expression, or because like this, like the whole expression of this variable assignment is like, this is an expression, not the whole variable assignment. So yeah, that's a good question. Let's check. Okay, cool. So it does actually. Yeah, there is some cases where you're like, I don't know whether this is like a top level expression versus like just a part of, say, like an if check that has like, 7 nested parts. There are sort of like special syntaxes where you can say like, I don't know where this is, but like match it anyway. But yeah, I wasn't sure if in this case that would match. But yeah, great question. And fortunately it does.
One more follow-up question. Actually, there might be two, but does it support a feature similar to regular expressions, non-capturing groups? Because it looks like the ellipsis has captured the puts statement.
Yeah, just to clarify, do you want to be able to like grab a reference to the puts, or can you tell me what you?
I mean, like, I want to be able to exclude the puts from the statement which matches the OR rule. Right now, it looks like it's highlighted, and I want to exclude it from the statements which are captured.
Yeah, that's a great question. So I guess to explain like why that's being highlighted, basically what Semgrep is doing behind the scenes is it's like taking the test code and your pattern and abstracting both into trees, and then it's doing sort of like a smart tree match. And so the reason why each of these is highlighted is like, okay, well, we started the match here and then we matched through this. So there are some cases where you can sort of restrict the match a little bit better. In terms of, there's another one of these clauses where you can say like and is inside. So sometimes you can cleverly use those to say like, okay, here's the exact thing I want to match, and then here's like what's happening locally to sort of filter some things out. In this,
cool stuff. It's cool stuff.
Oh, thank you so much. Yeah, so in this case, honestly, I'm not sure how to do that best, but there are, like this is actually one thing we're actively working on, to be honest, because sometimes you'll be matching things that happen, say, 10 to 20 lines apart, or like 50 lines apart if it's like a very big function, and really it's just like 2 lines that are sort of like the critical part. We have some ideas about it, but it's like not super obvious how to fix this in the general case. Like we've been talking about like, oh, maybe you can like give a label to these ... dots and like exclude them. Yeah, it's something we're like thinking about and working on, but I think there's not a obvious way to do that today, is my answer for now. But it's something that hopefully in the future we'll be able to do a little bit more precisely. But yeah, thank you so much for the question. Yeah, any other questions?
Yeah, I have one. I don't mean this as a gotcha question at all. I just want to know how this works. But if you had like a send in here where you were sending : would this rule catch it?
Yeah, that's a good question. Yeah, so so one thing interesting about Ruby is, yeah, there's like a bajillion ways to do things, especially with Rails, where like so many things happen because of like method missing, and sort of like dynamically either using metaprogramming or other methods. Like the runtime knows that this is actually what's going to be called, but like statically it can be difficult to determine. So I guess I have like maybe a couple of answers for you. So in general, I would say things like very dynamic language features like reflection, send, eval, things like that. It's difficult for any static analysis tool to reason about that just because of like fundamental like halting problem type things. There are some cases that in theory Semgrep could reason about. I would say in practice it probably doesn't yet, but there are some. Like if you were to say like, what are all like the crazy ways you could call or do something, I would say definitely any static analysis tool is not going to be able to handle all of them. But I think there's some of it that is possible statically. And of that possible, I think Semgrep does some of it, but not all of it yet. So I would say for now, I don't think it resolves calls to send and things like that, but some subset of that problem I think it could do in theory. But probably not every case. So there's certainly like fundamental limitations here that just cannot really be resolved.
Cool, thanks very much.
Yeah, no problem. There is like one example of that is perhaps interesting is like import aliasing. So because Semgrep supports a number of languages, like different language features are supported better or worse in different languages, like as we just mature support for them. So in Python, I think not yet in Ruby, but I know in Python we support import aliasing. So if you were to say like, actually I can maybe just bring it up. Yes, there's a bunch of like built-in examples that I can show you stuff. No, that's not the one I wanted. Yeah, so this is Python, but you can say something like, say you were trying to find calls to exec, but someone were to import it locally as a different name, like safe function, and then call safe function on something. So Semgrep can actually resolve that like this name actually means something else within this scope. So I think its functionality in Ruby is currently limited in that sort of like import resolving type thing, but that is like one example of something that is a little bit non-obvious, because like notice that the rule doesn't have any logic about handling import aliasing or anything like that, but Semgrep actually transparently handles that for you. You just don't even have to worry about it. But yeah, but I think it's still, Ruby, to be honest, is like one of the early or more recent languages we've added. So there's still, it has like reasonable support now, but there's a bunch of things we're still planning to add. But eventually we'll have a bit fancier stuff too. But yeah, great question. Thank you. Yeah, so feel free to chime in with any other questions. If not, I'll go to the next example. So let's say this is an example of just like some business logic check that you want to make, like, hey, let's say it's a financial trading application and we just have this business logic where before we call make transaction on an object, we want to make sure that it's verified first to make sure it has the proper state. So like this first example is okay because we're calling verify before make, but the second example is bad because we're just calling make directly without verifying first. So you could imagine like just setting up some global state, or really anything in which like foo needs to be called before bar is an example of this. So there's like some other examples of like, well, what if you call make before verify? That could also be bad. If you only call verify, like that's fine because we're not doing sort of the state changing action. And then maybe there's like other statements in between. Okay, so like how would we enforce the calling order of some APIs? You could do something like this. You could say like, well, let's find any method. Don't care what the arguments are. And maybe there's like some stuff at the beginning that we don't care about. Sometime it's going to call make transaction, and then maybe some stuff happens afterward. So basically, this is going to find any method in which make transaction is called at all. And we don't really care about too much else that's happening. So this is sort of like a broad swath. We're matching lots of stuff. But of course, we're matching some of the things that are actually safe. Like, if verify is called first, we probably don't want to match that because then the state has been properly verified. So what we're going to do is filter out and is not. So we can just like copy this down and say verify transaction. And maybe some other stuff happens. So basically, like logically, what we're saying here is like, okay, find every method that calls make transaction, filter out all the ones where verify is called first, and hopefully that is what is potentially bad. So, okay, so we didn't match verify called before make, that's good. Verify wasn't called at all here, so that's good, or that's bad, and we are appropriately flagging it. If they're called in the wrong order, that's also bad. Verify only is safe. Here there's other statements, but it's still make transaction called before verify. But actually this last example is interesting because here a transaction object is getting passed into the function. But actually the transaction that's being verified and made are actually different in this case. So we actually have like another assumption that I sort of been whitewashing so far. Like, oh, actually, we really want these two to be the same because if you're verifying something and then making a different transaction, then maybe the state in that transaction object is actually wrong. So actually what we can do here is use a meta variable to say, and one thing about meta variables is that within one pattern, they're enforced to be the same. So by having the same $t here and here, we're saying basically the variable passed to the first needs to be the same as the one to the second. So if we, with that addition, instead of ... which matches anything, we're being explicit about this is exactly what I expect to match. Now this last issue is flagged because other is not t. Yeah, so basically this is how in about maybe like 10 lines of code to match sort of some implicit assumptions about how API calls, the ordering of how they should happen. Yeah, any questions about this one? Cool. Yeah, well, feel free to interrupt whatever. I just have one more example for you. This one is a little bit more complicated and shows an additional feature a little bit. So let's say we have application controller, which implements some like CSRF protection or some sort of helpers like authorization or authentication that we want to make sure every controller inherits from it ideally. So we want to flag any controller that is not inheriting from the application controller. So let's take a look at how we might do this. OK, so here's like some test cases. Here's our application controller. We want everything to inherit from that, ideally. So OK, this one does. That's great. This one inherits from another controller. So ideally, we probably want to flag that. This one doesn't inherit from anything. We probably would want to flag that. And in your code base, these would be across many files, but it's just the sort of UI here only shows one file at a time. So that's why I'm putting them all here. And then maybe we have some other classes that we probably don't want to match. OK, so let's sort of one thing that's kind of nice is because it's like relatively easy to iterate, you don't necessarily need to have this like grand plan about how it's going to work ahead of time. You just sort of like write a few things, see if it matches what you intended, and if not, you just sort of like make some changes. OK, so let's say we're trying to match like some controller that's inheriting from something else. It's like, OK, well, we're matching a couple things, but really, like this is the happy case. Like we don't want to match that. So maybe let's filter out any class that's inheriting from application controller. That's good. We don't want to flag that. So we can just like filter that guy out. And I guess like we should probably filter out sort of this the application controller itself, because that's intentional. Yeah, so one thing like interesting here is you can use like dot dot dots and meta variables and things like that, but you don't have to. Like here, we're just doing it directly, and so that will match exactly that. So OK, so we're only flagging now this this one that is not inheriting from application controller, so that's nice. But there's actually like these other cases where this one's not inheriting from anything, which like realistically, I guess this can't happen in this case because it would need to at least inherit from like action controller base or something like that. But just for this example, like, oh, and then this is a subclass this isn't a controller at all. So let's see. So how can we do this? Well, maybe we just want to do a general, like, it doesn't have to inherit from anything. So then that will flag a couple of other things that we kind of wish we didn't, but it will at least capture this one, which we did want to. So basically what we want to do here is like, well, if we assume that we're using the right naming convention of the class being like something controller, then we could perhaps filter out these cases that are like not actually controllers. You can actually do this by path as well. Like if it's not in the controller folder, you can actually specify that in your pattern as well. But just because I think this is sort of interesting functionality. So far, we've been using this like simple tab, which is like this nice sort of like composable UI, but actually underneath all Semgrep rules are just YAML. But writing raw YAML can be a bit of a pain, so we created this nice UI on top of it. But if you go to the advanced tab, you can see what this actually looks like, which is it has a rule ID, this patterns clause that basically has a series of things underneath it. We can see pattern eithers, like either of these are OK, pattern not, so we're filtering out these. And then basically what we're going to do here is use another clause called meta variable regex, which actually does exactly what it sounds like. Basically, we're going to apply a regular expression to a meta variable to say like it needs to look like this. So we can say meta variable. We've been doing controller for the sort of like class name that we're matching. regex is dot star. So like it could be anything, but it's going to end with controller. So basically, in each of these clauses up here, this controller, these guys, we're now going to say only match if that, basically the whatever text we've extracted out of there matches this regular expression. So if we run that, we can see that we are, so bar controller does end with controller, as does ZOMG. But these previous things that were false positives because they were not actually controllers are no longer matched. Yeah, so any questions about this one?
What does that look like in the simple UI?
Yeah, so that's a great question. So if you were to click on simple, it basically warns you to say, unfortunately, the simple editor is not feature parity with everything you can do in Semgrep. So just we haven't like fully thought through like how should this be composed? What should it look like? So it basically will erase things that are not supported in the simple editor for now. And the reason that we're doing this is because so in YAML and in Semgrep rules, you can sort of like arbitrary nest different clauses in terms of like you could say pattern not, and then like pattern either, and then pattern like inside. Like it could be like arbitrarily complex, which to keep the simple editor from like sort of looking like this monstrosity, we had to make some simplifying assumptions about what patterns we would support in the simple editor. So eventually it'll be able to do more things, but for now we've sort of constrained what's expressible in the simple editor, although in the advanced mode you can do more. So that was a long way to say currently you can't view this rule in the simple editor, but hopefully eventually you will be able to.
That makes sense. Is there a way to check for the case where other controller inherits from application controller if you have a nested hierarchy?
If another controller inherits from
the other controller. Yeah, line 30, 13-ish, 12, yeah.
Oh, so if other controller inherits from application, so it would be something like, yeah, something like that you're talking about?
Yeah.
And then so like this would actually be safe because in sort of the class hierarchy, it is descendant from an application controller. Yeah, so that's a great question. So the answer is currently Semgrep focusing on sort of like localized analysis does not do a full class hierarchy. And also the way sometimes things in Ruby like extend different modules sort of like based on like conditionals and like potentially crazy things. This is, I would say in general in dynamic languages, potentially a hard problem to solve for static analysis. I think that we could do a pretty good job in general, but currently we don't build a full class hierarchy because we're focusing on trying to be fast and running even if you don't have all the dependencies, which like you would need to fully resolve all types. We have been experimenting a little bit with LSP, if you're familiar, the language server protocol, which is pretty rad. Basically, it's what VS Code and a number of other editors use, which basically is like, how do you get like code completion, jump to definitions, and like all these different things in like VS Code or any editor that supports LSP. So we are actually experimenting with using this sort of thing to resolve types, and that would allow us to do things like this. So this is on the roadmap, but not currently supported. But yeah, that's a great question.
Cool, thank you.
Yeah, no problem. So like if for example, you had like an API controller, which you know that a number of other controllers also inherit from, that does inherit from the application controller, you could add like another pattern not that's like, oh, this is like another parent class that's okay. So that's like a sort of a hacky like works for now sort of thing. But sort of full class hierarchy resolving is not currently implemented, but it will be hopefully one day. Cool. So these are basically the examples that I wanted to cover. Just like a couple of other features that we didn't have time to talk about. So one thing is where like, well, we aren't going to be able to predict everything that people are going to want to do in practice. So we actually created this clause called pattern-aware Python, where basically you can write arbitrary Python code and you get passed to the meta variable, so you can do like whatever you want inside it. But we acknowledge that that's like potentially dangerous, so you have to pass in this like flag that's like, hey, I acknowledge that like if I'm using a malicious rule that like runs some code on my machine, like it could do whatever. But so you can actually write arbitrary Python in a Semgrep rule as well if you need to like extend its current capabilities. Ideally, we want to be a tool that like doesn't just point out errors, but actually makes fixing it easy. So we have another key that called Autofix, where basically you can say, oh, I want to match this. For example, if you are upgrading to a new version of an API or deprecating an API, you can say, oh, just use this instead. And then, you know how in GitHub or other platforms that'll say like apply recommended fix, you can basically do that. So currently the sort of replace is a little limited in terms of it's mostly like a text replace. It's not doing like a complicated sort of refactoring, but it can help in some cases. So we talked about just a couple of the things Semgrep can do today. There's a bunch of other clauses that I think we didn't talk about, but our docs sort of say, here's all the things you can do. If you want to, there's a bunch of examples. If you go to the editor that I've been showing you, you can just sort of walk through them. There's also a tutorial. Feel free to check out that as well. So again, limitations, I think your questions have been excellent. They've been pointing out a bunch of them. So just some examples. Semgrep rules aren't Turing complete. So unlike, say, Rubocop or Brakeman, which are like arbitrary Ruby, in general, we sort of like when you're creating a tool, you have trade-offs between like, do you want to make it like fully like pro mode, it can do anything at the expense of being a bit complex and potentially hard to use and have a low barrier to entry, versus like, do you want to sort of constrain things a little bit in that it's easier to get started and easier to do the easy cases or even some of the medium cases. That's kind of like where we've made the trade-off so far. Another current limitation is Ruby support is just maybe like a month or two old, so it may have some parsing bugs. So if you come across them, please let us know. We'd love to fix that for you. And in terms of sort of built-in rules you get out of the box, again, because it's newer, we have more rules for other languages, but you can easily write your own. So if you're like, oh, this is great, but maybe I don't have time to write a bunch of things myself, so we do have a sort of public registry of things written by us as well as the community. You can go to semgrep.dev/explore to have like a nice UI for it, but it's actually just a bunch of YAML files in this public GitHub repo. So if you'd rather, you know, like show me the source, you can do that too. Yeah, so one thing that's been pretty cool is as we've been writing rules, other people have actually been contributing as well. So Damian Grisky, the author of Go Perf Book, has been churning out a bunch of like code quality and best practice rules for Go. Node.js Scan, which is the most popular JavaScript security scanner, its underlying analysis engine and all of its rules are actually written in Semgrep rules now. So we've actually ported a couple of other security tools like GoSec and FindSecBugs, which is Java. We've ported some of their checks to Semgrep, so you don't need to compile your target anymore, which is kind of nice. We've got submissions from the creators of frameworks like Django and Flask. Some people doing security research have been using Semgrep as well. And we've been working a bit with OWASP, which is an awesome community that mostly focuses on the sort of web application security and ideally trying to sort of support the community however we can. So yeah. Anything you would like to write and contribute back, we would love to see it if you want to. Okay, so if you think this sounds cool, how do I integrate it into what I'm using now? Whether that's enforcing coding standards or security best practices or whatever. It's pretty easy to integrate. Basically, there's a Linux binary, there's a Docker container. You can pass like --JSON to get JSON output. So really like whatever you use, you can pipe it to your various systems. we do have some like example, there's a GitHub action you can just use directly, or we have like example sort of snippets you can include for, you know, pre-commit, GitHub, GitLab, CircleCI, AppVeyor, Travis, whatever. Yeah, so that's basically it. So today I've tried to make the case for why writing org-specific lints is useful, either you know, helping new developers get up to speed, shipping higher quality code, fixing bugs at scale, things like that. Whether it's Semgrep or another tool, I think some key properties that are useful to keep in mind are, you know, how easy is it to write custom checks, like for my code, because, you know, generic checks may not understand how my code works. Ideally, it's fast, and ideally, it's easy to integrate into CI. There's a link to the open source repo. You can just go here to see the current slides that I just showed you today. And yeah, feel free to reach out. I would be happy to chat with you. So yeah, any other questions? I'd be happy to dig into anything in more detail.
Yeah, I do have a question about. I'm interested in knowing like how much overhead there is to like implement a new language. For instance, when we're looking at like the last example you show with the class and the controller and the inheritance between controllers, I was wondering if like, is Semgrep aware of these are classes and we're talking about inheritance, or is it at a higher level where it's only looking at the code from a semantic standpoint?
Yeah, so that's a very good question. So in general, I would say for most static analysis tools, adding new languages is very difficult because you need to have like a parser that handles maybe multiple versions of the language as the language evolves over time. You need to be able to turn it into some sort of consistent like abstract syntax tree that you can then sort of analyze. We've actually done kind of a clever hack, in my opinion. So if you go to, let's see, GitHub, there's actually this project from GitHub itself called Treesitter. And basically, Treesitter is this sort of series of grammars for many different languages that's, I believe, used by Atom. But basically what we do is, so Treesitter is a grammar for like, basically this is how you parse many different languages. So what we do is we sort of incorporate the various grammars from Treesitter to sort of prevent us from having to write grammars for new languages from scratch. There's still actually a fair amount of work involved, but it does save a fair amount of time. And we do push back fixes to Treesitter, like their TypeScript support was not as great until we made it a lot better. So yeah, basically, because Semgrep is aware of language constructs, like this is a class, this is a module, this is a function call, and things like that, we do need to have basically solid parsing grammars for every language we support. So that takes a non-trivial amount of upfront engineering effort. But I would say it's on the order of weeks to a month or two to get sort of initial support. And then there's always sort of like edge cases and bugs and such that need to be fixed. So I would say it's not trivial to add new languages, but it's feasible. I would say in the past, maybe 4 to 6 months, I think we've added 2 or 3 new languages. So we're constantly adding new ones, and probably we'll have another language or 2 in the next 3 to 6 months, I would expect.
Thank you.
Yeah, but if you're curious, actually the internal, the part doing like the fancy program analysis of Semgrep is actually written in OCaml, because a lot of the sort of programming languages PhDs and academicians who are sort of experienced at doing all of this, for example, or for some reason love OCaml. So that's actually the background of why Semgrep is OCaml, because the guy Johan Padalu in his PhD at INRIA used a lot of OCaml. So sort of that's why the fancy stuff internally is OCaml. But yeah, thank you. Any other questions? Yeah, unfortunately, I don't know if we'll have time, but I was hoping maybe to even if we had some like an extra 10 or 15 minutes, like somebody could just say, oh, here's like a code pattern I want to find. And then we could just like try finding it live. So I don't know if we have time to do that, but I don't know. Feel free to give it a try on your own and just like send me a message to be like, hey, oh, I guess one thing that I perhaps didn't emphasize is like if you create a snippet and you're like, hey, this doesn't work, and you click save, you can actually send anyone this link. Like this is private browsing mode. And so basically the reason I show you this is like, oh, if you're like, hey, I'm trying to find this thing and it's not working, feel free to like create a link and send it to me, and we can take a look at it.
That's great. Thank you so much.
Yeah, thank you so much for having me.